to point out real quick the little announcements up there. We do that quiz that we talked about before tomorrow, and then I added some more stuff. And I don't know how many of you guys realize. You guys realize yet that you want more grades? Mm-hmm. Did I tell you about the class I had that? Like I just mentioned it. There was a class I had. The only grade was the oral final examination. So they put us in rooms and gave us a problem, and came back and said, "How you doing there?" Anyway. So you want more grades. So we're gonna have a couple quizzes in quick succession. I did move the test date back because we had that one power outage day. It kind of pushed us back, so I'm gonna move the test back. Okay. And of course, after I said all that, I completely forgot your questions.
I was wondering if we could just go over slope-intercept form.
Slope-intercept, okay.
And how to divide it by imaginary numbers.
Okay, so let's do line equations first. Slope-intercept form. What is slope-intercept form? You guys, can somebody just tell me what the form is? Good old line.
We're talking about like AX or
What's the letter for slope? M. So what's the equation of the line? Y equals mx plus b. Cool. All right, I like it. And we all know it, but we're like, is that what he means? All right, I understand that. So the most basic equation of a line is that guy. And real quick, why the hell does that make sense? So think about this. Where are the intercepts? Where are what we call the intercepts? How would you tell me very quickly without coming up and pointing to it where the intercepts happen? Where's the x-intercept? Yeah, when it hits the x-axis, correct? So that's the x-intercept. At the x-intercept, what is the value of y? Because here it's 1, here's -1, so at the x-intercept must be 0. And the same thing for the y-intercept, x is 0. You with me? So the funny thing is, one of my last math classes I took, I had an equation that had like 15 variables. Yeah. So if I wanted to find the w-intercept, I just made all the other letters 0. So the basic idea of finding intercepts, I don't care how many dimensions you're in, you just make all the other letters 0. So how would I find a y-intercept of this here? I would just make what 0? X. So b must be the y-intercept, correct? Whatever number's there must be where it hits the y-axis. How are we doing so far? So again, we didn't just plot this down and go, yeah, let's say b is the y-intercept. No, it just is. It just is, because that's what you get when you put a 0 in. Okay, maybe. Maybe. Now, what if I had, for example, y equals 2x plus 1? Let's examine why that's the slope, right? Let's see why that makes sense that this would be the slope. What do I get when I put a 1 in there? 3, right? Twice 1 plus 1 is 3. What do I get when I put a 2 in there? 5. 11. What do I get when I put a 3 in there? 7. So, since the 2 is in front of the x, every time I change x by 1, the output is going to change by 2. So I think of it as an amplifier. Whatever number is in front of the x, it tells me as x changes by 1, y will change by m times 1, m. And what does the slope tell you? How much y changes as x changes? Yes? So of course the number that is sitting in front of the x when it's in that form is the slope. Okay. We're almost done building the college. All right, is that, I don't know, is that better? I mean, it's always good to know, why is that the slope? Why is it the y-intercept? Did we just pick it that way? No, it's got to just be what works. It's got to be what makes this happen. Okay, that's one thing. Do you have a specific kind of question?
Not really.
Okay.
I just, so the denominator is how much you go over.
Oh, okay, let's do this.
That one also
Graph.
confuses me.
Let's do this. Graph y equals 1/3 x minus 1, right? Let's graph this. And I know that we have a little graphic calculator, it can do a lot of good stuff, but I need to see some work. And by the way, you need, yeah, what? Thanks, man. Everybody else all right? Anybody else need this? Okay. Can anyone tell me anything about this line? Anything?
The y-intercept will be -1.
All right. In fact, let me be a little more specific. Y-intercept will be
0.
I love it. Kick ass. Why is it true? Because is it in the right form? Yes. So then everything just falls into place. We're going to see that happen so much this semester. We're going to work with circles. And if we put the equation in a certain form, we'll see the center of the circle and we'll see the radius of the circle. There has to be a connection between the equation and the shape. So if we just put things in the right form, I can just see the main aspects of what the graph would look like. Are you guys semi with me? Because the equation is what generates the freaking shape. So of course there should be a connection. So if I put any line in this equation, things fall into place. Now somebody else tell me, what does this tell me? Slope. Oh, I heard it. What's up? Rise over run. Kick ass.
Okay, now it's coming back to me.
Rise over run. By the way, quick little question. Have you guys ever driven around, like I think Mission Hills is where I used to live, and there's a nice steep road. Have you ever driven around and seen like 7% grade or something? One time I was hiking, there was a 12% grade, and that, we didn't go back up that way. I didn't feel like. We went down that way on our asses, but anyway, 7% grade. Believe it or not, that's a slope. What's 7%? What's percent mean? It's 7 out of 100. So it's rise over run. 7. So I rise 7 as I run 100. That doesn't sound like much, right? But it actually is. It's quite different from flat, right? And then when you get to 11%, 12% grade, then you're starting to get like, oh shit. Yes? Is that, all right, did anybody know that already? All right, I like it, but somebody, all right. So that's what that means. It really is just the slope. I just write it as a percentage because I make it out of 100. Okay, maybe. So what the hell what can I use this for? How do I get the graph from this? Well, what point do I plot first? Yeah. This is always the most exciting part. It was riveting, Jeff, watching you do that. So so the y-intercept is 0, -1, bam. And then what's the slope tell me to do? Right? So from there I'm gonna rise 1, run 3. There we go. That's pretty good for me. How do I check that, by the way? What point did we sort of get magically? This point, we got this point a little bit, not magically, but we just got there by just walking over to it. So what point is this?
0.3.
No.
3-0.
3-0. Now, if the line goes through that point, this point should do what? What should this point do since the line goes through it? The line will only go through points that answers the question, right? Should work in this equation. So when I put a 3 in, what's 1/3 of 3? 1 minus 1? Freaking 0. Shit. So every time you graph a line and you kind of walk over to a point, you can check it real quick. Whatever that new point is, plug it in. It better work. Okay, how's everybody doing? Thanks. I like it. Is that better? So I know a lot of this stuff can leak out really easy, but once you see it a little bit, it's going to come back. I like it. Okay. Anything else about that? One more quick one. I'll do one more quick one with this, and then we'll move on to, from this, we'll go to dividing by complex numbers. I'm going to erase this. Everybody ready? All right. How do I create the equation if I'm given that, given a line goes through 1, -2, you can do it, Jeff, and 4, negative, let's make it 4, 5. Yeah. Find the equation. Here's a quick way I'm gonna write equation. How do I do it? I don't even do it right. There, I don't normally do that, but I'll find the equation. Yes?
Is there y2 minus y1?
Ooh, sweet. So from the general form, I need a slope, and I need to know what b is. I need the y-intercept. Did I give us the y-intercept? No. So I'm going to do it kind of two ways. But like you said, so I need slope, and I need a point. Well, do we have a point?
4, 5?
We have 2 points. So we have an abundance of points. So you can pick one, right? So you want to pick 4, 5? I love it. Now, you just said, I believe, what's the equation to figure out the slope?
y2 minus y1.
Yeah, over.
Over x.
Now, how does that relate to slope in English? How does
Right.
rise over run? And when I rise, what axis am I moving along? The y-axis. So, of course, the top is how much the y's change. That would be rise. And what's cool is rise freaking rhymes with y's. That's awesome. And then if I run, of course, I'm changing along the x-axis. So the equation for the slope makes sense because it's how much the y's change divided by how much the x's change. That's rise over run. So this would be y2 minus y1 over x2. What do little 2's and 1's mean?
Y.
The points. I love it. And to be really honest, we really don't need them. We just need to say if I take the second y minus the first y, it's got to be the second x minus the first x, or else my slope might have the wrong sign. Okay, cool. That's all those are there for, to be honest. So if I go 5 minus negative 2, right, y2 minus y1, over 4 minus 1, I could have done negative 2 minus 5 over 1 minus 4, and the signs would have canceled, and it would have come out the same. What's this? 7/3. Not the slope you wanted, but the slope you needed. All right. So what do I do from here? There's two things you can do from here. Let me show you the standard way, and then I'll show you the slightly less standard. Does anybody know another equation for a line besides this one? I'll get it started, see if anybody remembers. Y minus y1 equals
X minus x1.
m times x minus x. I love it. And notice real quick, and again, this is not a lecture, this is just a review. Notice if I see this, if I multiply this up, don't I sort of get this? Just I took the 2's off of this one. Because does it matter what 2 points I picked to get the slope? If I have a line, does it matter what 2 points I pick? So that's why one of them I could just say, this one's any point. That's why I can take the little 2 off. That's where the equation comes from. All right. Why is this one good for my situation? Because I don't have the y-intercept. That's what B is. Here, I've got a freaking point though. Shit, we picked this one. You could have picked the other one. It would have worked. All right, how are we doing so far? Is this coming back? Does this seem familiar? If this seems completely foreign to you, come see me. Holy shit. But this you need to go, okay, it's been a while, but I kind of remember doing this. Yeah.
What formula is that you just wrote down? The y minus.
This one is funny. Math people, some of us lack some creativity. So we said, what are you going to call this thing? This is a point, and there's a slope. We'll call it point slope.
Okay.
So this is point slope, right? The lesser known sequel to point break. And this one we call, of course, slope intercept, yeah. Because again, we're remarkably creative people. Okay. So now I can just plug it in, right? Y minus the y piece of the point. Well, what's the point we picked? 4, 5, so what goes here? 5, the y piece. Y minus the y piece equals m times x minus the x piece. 4. Right, and then you can just distribute the 7/3 and add the 5. Is that cool? You okay? I don't know if some of you guys are like, I'm not gonna tell you anything, John. Maybe. And again, in class, I need to kind of go a bit and get over some things, but if you have trouble with this or something, anything we do, and I don't have enough time to kind of cover it in class because I got stuff to do, just come see me. See me after class, see me in my office hours, come early, I'm here before class, right? Okay, I like it. And real quick, and again, distribute, add, blah, blah. Another way you could do this, if I use this equation, believe it or not, I can use this equation, even though I don't know the y-intercept, because I do know the slope, and I do know a point. So I know the slope is 7/3, yes? And this equation, what points on the line should that equation work for? Which points that are on the line should that equation work for? Kind of a trick question.
All of them.
All of them, shit. So, can I put 4 or 5 into this equation? Yes. So the output would be 5 when the input's 4, and then you can just solve for B. So that is the other way to find the equation of the line. Maybe? Does that seem at all familiar, either of those? Okay, all right. So now let's talk about your second question, which was, sorry, go ahead.
Relating to that question, because for the specific question in the homework for 22, it asked for 2 points, and I did it in the y-second method, like the formula we did right now.
It asked for 2 points?
Yeah,
Let me take a look. You said which problem?
for 22.
22. Oh, let's see. It's chapter 2, is that right?
Yeah.
Shoot. 22. Is that the quadratic one?
No, it was also like the using
Oh wait,
the
I'm looking at the wrong thing,
pencil.
sorry. Here we go. There it is. Oh, yeah, that's like this, that's exactly like this problem.
But when you subtract 5 from 5
Oh,
from
okay.
0,
And it's asking, yeah, okay. All right, I love it. So there's a problem that says 5-1 and 5-7, is that right?
mm-hmm.
If I plotted those points, what's a little weird about them? If I plot those points, aren't they both like, here's 5-1 and here's 5-7? Aren't they straight up and down from reading each other? Do I run at all? It's nothing but rise. So what's run then?
0.
0. So the slope would be something over 0. So the slope is what? What do you call it when you divide it by 0? 2 things you could call it. Undefined or infinite. I love it. Because it's infinite slope, right? So here's the question though. The question says, what's the equation? Now here's something you desperately need to understand. How would you define all the points on this line to somebody? What's true about any point on that line? You could do this.
X equals 5.
5 is 0.
X equals 5. Done. That's the equation of the line because it describes the line.
Y is all real numbers.
Say again?
Y is all real numbers.
Y is all real numbers, exactly.
Huh?
Y is all reals, yes.
Yeah.
But that's not the equation of the line. It's not
Oh.
specific enough. Y is all reals could be over here.
Okay.
X equals 5, that's descriptive. And why does this also tell me that Y can be anything it wants to be? Because Y is not restricted. Is Y even in here? No. So it can do whatever the shit it wants to, just as long as X is 5. You guys see that? Coolness. Okay. And in fact, can I put it in this form? Can I solve this for Y? Can I solve this for Y? Is there a Y in here?
No.
So can I solve this for Y? No. And that kind of also says, well, then the slope must be weird if I can't solve for Y. So the slope is infinite in this case. This is one of those special cases. So if I had a line like this, what kind of equation would it have? Y equals, because then Y has to be constant. So if it's not moving left or right, that means X is constant. If it's not moving up and down, that means Y equals a constant. Okay, maybe. Maybe? Okay. All right, so So to do dividing complex numbers, we have to start with something a little more basic. Somebody help me out. These are in this homework set, if I remember correctly. If I wanted to rationalize something. Can somebody tell me, all right, why does that poor little dude suck so bad? Radicals are bad enough, right?
It's on the bottom.
And this one is freaking dividing by. All right, so one way we think we can improve it is to make it so the bottom is not irrational. So that's why we call it rationalizing the denominator, making it not irrational anymore. So I'm going to ask you a really silly question. Why can I not do this, but I can do this? 49 has 2 7s in it, and the square root's looking for groups of 2 things, yes? Whereas this one's only got freaking 1 7 in it. You guys with me? So I can only directly do the square root of something that has 2 somethings in it. Is that right? Square root of 25's got 5 5. Square root of 64's got 8 8. I can do this. Are you guys kind of with me? That's a really silly question, right? But do you guys, obviously that's true. Yes? So then, if I just have this, what else does it need so that it could be done? It only has 1 7 at the moment, so what does it need given to it? Another frickin' 7. If I change the bottom, though, I have to also... Okay, beautiful. So what's wrong with me doing this, then? Did we just say it needs another 7? Because could you do 7 times this 7? No, because it's in the radical, right? You can only multiply radicals if they have the same root. I like it. So I have to give it 1 more 7 in the radical. Now remember, I know this is coming kind of fast, and I told you the review sections have a lot in them, right? So, what is the radical? How can I rewrite that? Square root of 7 would be 7 to the what power? What's the square root do to something? Cuts it in. So 7 to the half power, right? So a cube root would be 7 to the 1/3 power, and so forth. You guys with me? We did talk about radicals versus fractional powers, I believe. Yes? Okay. So I'm not going to rewrite it, but isn't this half a 7 times another half a 7? Doesn't that just make a whole 7? Oh, I'm sorry. 2 halves coming together? No. So if you just look at it directly, what's 7 times 7? And square root of 49 is 7. But why even do that? Half of 7 times half of 7 is a whole 7. Do I get square root of 14 on the top?
No.
Hell no. You can't put the whole 2 together with a half 7. So you just got to do, bam, and there you go. Done. Now, I love it. Right now, you're thinking, what the hell has this got to do with my question? Right? I don't blame you. We're getting there. Does this make sense by itself? Does this sound familiar at all? All right. Next level of this. This is always a whole nother level. Right? Shit. Because now, if I multiply by square root of 2, this guy will be good, but will this by? Will this guy be okay? No. If I multiply by square root of 3, he'll be okay, but he won't. So somehow, I have to multiply by both of them, right? But in a way that the square root of 2 only goes here and the square root of 3 only goes there. How the hell do I do that legally? Well, does anyone know? Remember this came up before. It feels like we talked about this before, but
Square the whole equation.
I love that idea, but unfortunately, several things. If I have a number sitting there, am I allowed to just square it out of nowhere? Didn't I change the number? Are we supposed to change this number, or are we just trying to simplify? And when I simplify something, I can't change the value of it. If you think, well, I just square the top and bottom, Jeff. 2 problems with that. You can't square the top and bottom. What's the only thing you can do to the top and bottom of a fraction? Multiply by the same thing or divide by the same thing, right? You guys kind of with me? If I square the top, isn't that effectively multiplying by another square root of 5?
Mhm.
If I square the bottom, am I multiplying by another square root of 5? No, I'm multiplying by square root of 2 minus square. I'm not multiplying the top and bottom by the same thing. I'm not allowed to do that. You guys get that? Maybe? Okay. Otherwise, 1/2 would equal 1/4. 1 squared is 1, 2 squared is 4. No good, right? Okay. The other problem with that is, if I could square the top and bottom, what is this? Is it just 2 minus 3? No, because what do you have to do? Don't you have to write it twice? And FOIL? Won't you get a middle term? Do you guys see what I'm saying? Okay, this is kind of a good thing that came up, because what if instead of this, what if it was this?
The middle terms would cancel.
Middle terms would cancel, so the radical part would go away. Rad 2 times half of 2 times half of 2 is a whole 2. And then you get plus square root of 6 minus square root of 6. Die. And then you get, what's rad 3 times rad 3 was half of 3 times half of 3? 3. So then you do get 2 minus 3. You do get a nice number, right? So the idea, when you have more than one term of radicals, when you have 2 terms of radicals, you multiply by what's called the conjugate, which is just change the sign, which is like difference of squares idea, right? Where the middle terms cancel. So what do you get up top? Rad 5 times rad 2 is? Rad 10. So half of 5 times half of 2 is half of 10. Does that make sense? Plus square root of 15 over, and then we just do this 2 minus 3. We just did this one, right? That's 2 minus 3. So you get rad 10 plus rad 15 over negative 1, which you can write as negative rad 10 plus rad 15 or whatever. Yeah. Okay. So now, are there any radicals on the bottom? No. So there's still radicals in the problem, but at least we're not dividing by them. Yes? So it is like a little bit better. Okay. And I love you guys, because right now you're going, maybe like this, but it is a little bit better. So finally, what the hell does this have to do with complex numbers? Well, what kind of numbers do we call complex? Any number that has what kind of part to it? I think you're dying there, little dude. Poor little guy. Complex numbers, what do they have that makes them complex? They have a real part. Say again? Non-real number. So it's got a real part and an imaginary part, right? And we already talked about the fact that the word imaginary is a bad choice. That doesn't mean we just made that shit up. And to be really honest, we made everything up. The number 2, didn't we make that shit up? We didn't make up what it represents. It represents 2 things. That idea exists. But the simple 2, we made that shit up, right? So as far as nothing is made up, imaginary numbers are not made up either. They actually exist, right? And that's what I was hoping you got from that video. They're there. We just don't normally look at them because they make everything very true. Okay. So, what if I had 3 over 5 plus I? See how that's a complex number, right? Real part, imaginary part. So, remind me what I is. Say again, sorry. It's not negative 1. Yeah. If it was negative 1, why would we call it I? We're cool with negative 1. Square root of negative 1, that's some weird shit. That's that halfway thing, right? All right, maybe. So, everything that we do with radicals could also apply to these, because these are just freaking radicals, right? Are you with me? So what did I do when there's rad 2 minus rad 3? I multiplied by the same thing with a plus in the middle. I multiplied by the thing with the opposite sign in it. So what could I multiply this guy by? 5 minus I, kick ass. Same idea. All I is, all that I do be, is a radical. So whatever we did before to help with radicals, we can do with the I stuff too, because they're just radicals. Let me stop for a minute. Does that make any sense? So if this made some sense, this has to, because all I is a special kind of radical. So I do the same thing I do if I see any other radical down there. I attack it with what's called the conjugate. Now, remarkably enough, this is called the complex conjugate. Ooh, okay, it's just a conjugate. Same way that these are conjugates. These are like difference of square buddies, right? Maybe. So I'll do the top because that's really hard. Whew, okay, now what happens on the bottom?
Is it 5 minus, or the 25 minus 1?
25. And of course the middle terms cancel, right? Minus 5i plus 5i. Is that cool? These cancel. And then I get minus I times I. Well, what's I times I? I squared. Kick ass. Well, we can do better than that. What is I squared? Negative 1. It's the only thing that you square and it comes out negative still. Complex numbers, when I square them, they can actually come out negative. That is the property we're not used to. So then I get 15 minus 3i, become a 3, okay, over 25 minus negative 1. So I get 15 minus 3i over 26. Bam! Crazy shit. So once you figure out, given this, what do I multiply top and bottom by? It should just, now it's just distribution and foiling. That's all it is, right? The only hard part about this is noticing that I got to multiply by the conjugate, by the thing with the same, with a different sign. Yes?
Do you want us to like kind of simplify the top too? Because I know you could technically multiply 3 times negative 1, right? On the bottom, like 15 minus negative 3i.
Why did I put a negative 1 here?
That's what it represents.
What represents negative 1?
I.
No.
I quit.
I squared is
Oh,
negative
okay.
1. I is rad negative 1.
Right.
I really like that you said that, because again, a lot of students start to just go, oh, I is negative 1. If I was negative 1, why would we have it? We're cool with negative 1. Negative 1's fine. Totally makes sense. This doesn't make sense, so we have to give it a letter so I can just kind of make it easier to work with, right? Okay, I like it. All right, okay. Is that better? Okay. Anything else specific before we do a few new things? Anything else from homework? And by the way, if you just came in, just reminding you, the quiz tomorrow. Then we'll have a quiz on Thursday. Woohoo! And I am moving the test back a day since we had that power outage. That was exciting. Okay.
That power outage wasn't just La Mesa, it was at SDSU also.
Yes, it was. It went all the way over to Kensington, and it went up and over and down. Yeah, that was crazy. I'm glad we didn't wait for it to come back on, because it didn't come back on until like an hour and a half later or something. I can't remember. 2 hours. All right. So here's my little plan for the first part of today. Notice that people have been asking me, oh, come on, I want to do word problems. When are we going to? So they come up in chapter 2. So we're going to do this, I think. We're going to say word problems for the last thing about chapter 2. Inequalities. Solving inequalities. There's only one thing that makes inequalities, well, it's kind of two, that make them different from solving equations. So we'll see if that comes up. The other thing is you have to be able to graph them and write interval notation. We're going to see if everybody remembers interval notation. So for example, if I have x plus 2 is greater than 3. How do I solve that? Yes?
Minus 2.
Say again?
Minus 2.
Yeah, so it's exactly like solving equations. There's only one thing you have to look out for.
Can't be three?
No, you're overthinking. We'll see it. It's got to do something with negatives, right?
Which when you multiply a negative, you flip the sign.
Or divide. I love it. So we're gonna actually talk exactly why we do that shit. Yes? Alright, so here, this is just subtract 2, subtract 2. Did I divide or multiply by a negative? No. How do I graph this?
Open dot.
Alright, so in the past, you would have put an open circle in that, right? So we need to start using the correct symbols. So instead of an open circle, watch what happens when I erase part of it. Parenthesis, right? We use a parenthesis. And what does it mean if I use a closed circle? What does that mean? If I used a closed circle, why don't I use it here? Because I don't,
It's not equal to.
it doesn't include 1, yes? The answer, does it include 1? No. So look, the word include starts with an I, last time I checked. And if I erase part of that, doesn't that become a little bracket dude? So the parenthesis means don't include, like an open circle. And the bracket means include it, like the letter I for include, like a closed circle. Which way am I going to shade?
Right.
To the right.
The great thing about, if you have your variable there, that's an arrow that points you in the direction you're going to shade. Also, what numbers work, anything above 1, so of course I'm going to shade that way, right? And here's where I can make my Dragon Ball reference. So when he does the Kamehameha, right? Go like that! So here's 1, here's his hands, and here's a okay. If you don't watch Dragon Ball, it's not a prerequisite for the course. I just like that. Okay, does that make any sense? So everything I just shaded works, right? So if I pick 3, does it work? Yes, 3 is greater than 1. Everything I didn't shade doesn't work. So the weird thing about inequalities versus equations, equations have like a finite number of answers normally. Normally 1 answer. Inequalities could have an infinite number of answers. Okay, so what about here? Let's see, what do you got, John? Yeah, let's just do this. 6 minus x is less than 2x minus, doesn't matter now. Let's make it less than or equal to, just because. Less than or equal to. So I'm gonna do this. Just watch. I'm gonna choose to do something, and then we're gonna solve it a different way. So if I subtract 2x and subtract 6, right? I'll get negative 3x less than or equal to negative 10. Sorry.
I'm going to make that x positive.
Yeah, try to get x by itself, right? So what do I divide by? By negative 3. And of course, this is where somebody can pipe up what has to happen. That's going to flip. So there's 2 ways I can explain why that happens. The first way I love, and the second way is fine. Why the hell do we flip that sign? Well, tell me, real quick, tell me. Which is bigger between these? Which is bigger? Between 2 and negative 1?
2.
Yeah, holy shit. If I divide or multiply both sides by a negative 1, this becomes, and this becomes 1. Which one's bigger now? The 1 is. What happened? Sign flipped. So of course you flip the sign, because that's what you do. So when I multiply or divide by negative, don't I change what side of 0 I'm on? I was 2, now I'm negative 2. I was negative 1, now I'm 1. And now whatever was bigger is now smaller because I changed what side I was on relative to the other number. Does that make any sense? A little bit? Nothing? Some of you guys still have that poker thing going on.
It's only if you divide by a negative though?
Divide or multiply by a negative. Could be divided by negative 7, whatever. Multiply by negative 3. Whenever you multiply or divide by a negative, the sign has to flip. I like it. Another way to see why this works is, I think this is what somebody meant out there. If I do this problem again, but now I do this. right? So I keep my x positive. Then I divide by 3. But I want my x to be here. Right, so right now I got 10/3 is less than or equal to x. So x must, if 10/3 is less than or equal to x, x is greater than or equal to 10/3. Didn't I effectively change the sign? So if I can either do that, but I gotta realize, if I move the x's to the other side, I effectively switched the sign around them. So if I do this way, I have to flip the sign, because effectively it would have happened this way. Does that make there's 2 different ways to see why we gotta flip that sign. So then just do it. So in terms of solving inequalities, they're exactly like freaking solving lines, except when I divide by negative, I flip the sign around. Yes?
On the second example that you just used there, you said that, why do we have to change the x, like at the end, why do we have to put
Well,
the x?
again, tell me this. If 10/3 is less than or equal to x, x must be bigger than or equal to 10/3, correct? So if you just read it this way, doesn't it say x greater than or equal to 10/3? Okay, I like it. So if you're younger than me, I must be older than you, right? So that would just, okay. Yes?
I was gonna say, can you just like substitute the sign, make it equal to do it from there, then at the end, change the sign back?
What?
So I'm saying, so you have it 6 minus x is greater, is less than or greater.
Less than or equal to? Sure.
Just change it to the equal sign, you can do it from there.
Hell no.
Can't do that?
If you had a problem where you ended up dividing, multiplying by negative several times, are you just gonna keep a tally somewhere? Okay, now I turn it, and now I, you know what I'm saying?
Yeah.
So no, don't do that.
Okay.
Because then it's untrue. Right? If you make it an equal sign, it's not true anymore. Right? So trust me, you want to keep track of what it's doing, because you might end up doing something multiple times, and then you're like, let me just guess, 50-50. No. One thing I didn't do over there, or wherever the problem was, I can graph this. How do I graph this? Yes, on the 10/3, yes. And notice, I don't give a shit, really. I mean, if you don't know how to find 10/3 on a number line, that's a problem. So just put 10/3, yes? And there's gonna be a bracket. Now, which way is the bracket gonna face? And again, I like this whole thing about Dragon Ball, so he puts his hands together. So if I do that, see how if I'm gonna shoot that way, my bracket's gotta face that way? And then I shoot up, because that's greater than or equal to, so it's gotta go up. Now, what I didn't do in the last problem was, how do I make that interval notation? Interval notation is always, in the inside, it's the small number, comma, big number. So from this to this. So what's the smallest answer it could be? 10/3. Up to infinity. Can you ever get to infinity? So I never include it. If you do include it, I want you to show it to me. I think that was what was in the briefcase in Pulp Fiction, but that's just a theory. Infinity, holy shit. So you can't get there, so you don't include it. And in this case, what do I put on the 10/3? The same sign, the same symbol I used here. That's just a shortcut way without drawing a picture to tell somebody what the answers are.
Is the bottom one called domain and the top range?
No. Bottom and top of what? Sorry.
Isn't like domain like a certain format?
Domain and range apply if I have a 2-variable statement, right? Y equals 2x plus 7, then there's certain values for y and there's certain values for x, right? But here I've only got an equation with 1 variable, so domain and range doesn't really come into play. But I think what you're thinking is I can write domain and range using interval notation, yes?
I think so. Just
Yeah.
for the, like tests.
Yes. So if I had a parabola that started at 2 and went up to infinity, the range would be bracket 2 to infinity, because that would describe all the possible values of y. I love it. So yeah, we do use interval notation in domain range. Kick ass. Okay. So that's the basics on inequalities. Doesn't really get too much freakier after that. Where things get freaky with absolute values. And real quick, somebody help me out. absolute value. What does it do? What's the absolute value of negative 4? Why? I love it. Kick ass. So it's how far away from 0 something is, right? So if you're 4 feet away from me, you're not negative 4 feet if I turn around or something. Negative 4 mean you're like in, wait, right? No. So you can't have a negative distance. So since absolute value indicates distance, it's always positive or 0, right? So this is 4, because negative 4 is 4 steps away from 0. So the absolute value of 0 is, how far away is 0 from 0? 0. Yes. What about this? Okay, get ready. What is this? Nope. What can x be?
Anything that's not negative.
Anything. No, come on. Can x be negative? Of course it can. Is there anything telling me x can't be negative? No, x can be whatever the hell it wants to be. If it's positive, what would that do to it? Anything? No, it wouldn't do anything to it. If it's negative, what would that do to it? Change the sign, right? Now watch this. We said the absolute value of negative 4 is 4. What do we actually do to negative 4 to make it become positive? Multiply by negative 1. That is actually what happens. Now you can think of it as just taking the negative off, but that is actually what it does. If the input is negative, it changes the sign, it multiplies it by negative 1. If the input's positive, it leaves it alone. So this question is evil because I don't know what x is, right? The answer can't be x because then absolute value negative 7 equals negative 7. Is that true? No. So what we need to do then is we need to have one of these funky piecewise functions. So the absolute value of x, if the input is at least 0, 0, 1, 2, 3, or 1.7389, does the absolute value do anything? Absolute value is 7. What is that?
7.
So if it's 0 or more, does the absolute value do anything? Absolute value 7 is?
7.
Absolute value 3 is?
3.
If the input is 0 or more, does the absolute value do anything to the number?
No.
Keeps it the same. So if my input is at least 0, the output is x. If my input is negative, what am I going to do to it? Multiply by negative, right? So the output is negative x if my input is negative. So the mistake people make is they look at this and they say that's a negative number. No, it isn't. X is negative. And what's negative times negative? It's a positive number, right? That is weird looking though, isn't it? But you have to admit, the absolute value does two different things, depending on what the number is. If I don't know what the number is, I've got to capture both things it might do. That's what that does. That's what a piecewise function fundamentally does. It captures several, it could be 2 or more, things that the function does at different times. Could I have a rocket going on a straight line? Yes. Could it hit something and change? Does the function that talks about its trajectory change somewhere? Yes. So that would be why I have a piecewise function. At times up to this, it's going along this line, and then after that time, it's going along a different line. Maybe? Okay. All right. So what does this mean for us? If I want to solve an equation with an absolute value, I'm going to have 2 cases. I'm going to have 2 answers most of the time. So for example, if I said the absolute value of x, let's see example 1. Absolute value of x is 3. This one's nice because you can just reason this out. What would you put in there so the absolute value is 3? Or 3. So the answer would be 3 or negative 3. Yes? I love it. Does that make sense? That one's kind of in your face because you're like, well, what did I put in to make the answer 3? Well, 3 would make the answer 3 and negative 3 would make the answer. I can just see that. The minute I start throwing more shit in there, It's kind of harder to see, but it's the same basic idea. So let's do the next level. So what if I had the absolute value of, let's do this. X minus 1 equals 6. What's inside the absolute value? No, what's inside right now? Just what's inside? X minus 1. What could that number be to make the absolute value 6? What could X minus 1 be? No, you're overthinking it. What would I put inside the absolute value to make the answer 6? No, you're overthinking. I'm not saying what X is. Stay with me now. I got an absolute value of something is 6. What could that something be? Absolute value of what is 6? 6 or negative 6. So whatever's inside the absolute value could be 6 or it could be negative 6. You with me? So the thing that's inside could be 6 or could be negative 6. You guys see that?
Mm-hmm.
That's the same thing we said here. We just got to the answer because nothing was happening to the x. Here I got more shit inside, so the inside can be 6 or the inside can be negative 6. And now you solve those and you get to where you were getting earlier. So x could either be 7 or x could be negative 5. Now real quick, watch this. This is kind of cool. I say that a lot. I know. What time we got? Okay. So watch this. What does this? Tell me again what absolute value means. Distance, right? It means distance. So really, if I look at this, this is really asking me what number. I'm sorry. Let me write the whole thing. What number is 6 away from 1? This is what this is asking. What numbers are 6 away from 1? So if I put 1 here, what's 6 up from 1? 7. And what's 6 down from 1? Negative 5. So remembering that absolute value means distance, I can actually see the answer in a different way. I can just think of it by steps. Can I always do that? No, because the inside's going to get worse, right? And then it kind of doesn't immediately translate. But this is a nice, simple one. I can think of it like this. How you guys doing so far? So again, did I even need to look at it like this? Didn't I already get the answer? This is just extra. This is just me going, oh yeah, there's a whole other way to kind of think of this problem using distance. Okay, I love it. So you guys try this. Oh, let's do examples. I think x plus 5 equals 4. Solve that one real quick. So the main thing to remember, if I have an absolute value in my equation or my inequality, there's 2 cases to consider. Some of you guys are defiantly not trying this, but you know, it's up to you. I would suggest you should try it. So what's the first step here?
Split the equation into 2 equations.
Yes. So I could either have the inside equals 11 or the inside equals negative 1. And do you guys really fundamentally understand? Of course I can have the absolute value of 2 different things to get 11. And that's what's in there. So either that thing can be 11 or that thing can be negative 11 and it would work. And now I just solve for x. What x's make that happen? X is 6. Or x is negative 16. All right. Okay. So let's step it up. You guys try this one. What do you got, John? It really can't get that ugly, to be honest. Because you're gonna make two little linear equations, and those are relatively easy to solve, no matter what's in there. Alright, so either what? More? Yeah. So at least one answer is kind of nice, right? So minus 8, negative 5x equals negative 6, divide by negative 5. You get x is 6/5. Is that cool? This one's kind of nicer. Oh, Jeff, you think of it. Minus 8, negative 5x equals negative 10, divide by negative 5. X is 2. Bam. 2 answers. And just to throw one more thing in here, does anyone know what the absolute value function looks like if I graph it? What does x squared look like? Yeah, I heard it. It's a v. X squared is a u. Why does that make sense? It's not linear, so it's got to be curved, and it can't be negative because we're normally using real numbers when we're graphing things. That's why it kind of makes sense that it turns. It can't go negative. Same thing here, except is it squared? Is it cubed? No, it's to a first power, right? So it's got to be a straight line, but then it can't go negative, so it's got to turn.
Oh, it's opposite of one another.
Yeah,
Or it
so,
mirrors it.
yeah, exactly. It's a mirror image. So one, absolute value 1 is 1, absolute value negative 1 is 1. Absolute value 0 is 0, so it's just like that. So if I have absolute value equals a number, couldn't there be 2 answers?
Mm-hmm.
Okay, cool. Will there always be an answer? What if the number I pick was here? Is there an answer? It doesn't hit this at all, right? I'm just trying to explain to you why it makes sense. I should normally get 2 answers. So what's the situation where I wouldn't get an answer at all? Let's see. The easiest way to see an example where I don't get an answer, I'm on 3 or 4? Thank you. It's just to do something like this. Can you immediately see there's no answer? Why is there no answer to this? Because the absolute value is defined to be, and it's defined in such a way that the answer is always positive or 0. This one is saying, figure out when its absolute value equals a negative number. So you shouldn't do any work on this problem. But if somebody did do work, wouldn't they do this? Right? They would do this, they would get 2 answers, but neither one works. Because there's a fundamental problem with this equation. Absolute value can't be negative. So you want to look out for those, and you want to say no solution. Okay, maybe. If you did do those and you checked your answer, it wouldn't work. Okay, maybe. Does it make sense? That's why sometimes you get answers that actually don't work, because there's a fundamental problem with the initial equation. Another real easy example, by the way, is there an answer to this equation? Is there a number that is equal to 1 more than itself? The equation starts off bogus, right? It starts off impossible. If I try to solve it, I get 0 equals 1. And I'm like, what a discovery. Well, no, what is this trying to tell me? This works when this works. When does this work? So this don't work. No solution. So we see these kind of problems where I do everything right, but there's still no answer because the initial equation didn't make sense. So this equation makes no sense. And you're all like, I agree. All Okay. So things get, all right. So I just want to address this again. I know there's a lot at the beginning. I keep saying this, right? But there's just a lot to get through. And this is when you want to bring up questions. I am going to go a little fast because this should be sort of review, but I'm completely open to you slowing me down, asking me questions whenever you need to. Does anyone remember doing absolute value equations like this? Does this seem familiar? If you're not familiar with it, does it seem not too horrible? Anybody? It seems horrible to everybody? Seems horrible. You're like, well, I'd rather do nothing. Well, shit, not compared to nothing. Compared to other things you've done in math. Is this horrible?
No.
Okay, that's better. Thank you. We ought to make it relative. All right. So, what about absolute value inequalities? Okay, these get a little bit stranger. Let's see why. Let's start off with the most basic equation we could do. Actually, let me do it a little bit. Let me do this. Sorry. Oh, let's do it less than first. I'm sorry. I'm going on the fly. We're doing it live. So the absolute value of x minus 1 less than 2. So let's think about this. Since it's not a very difficult kind of inside equation, we can maybe think about this more physically. Absolute value means what? What physical thing? Distance. So this is asking me, what numbers are at most 2 away from 1? That's what this says. X minus 1 is a difference. Absolute value is a distance between number and 1, and I want that to be at most. You guys cool with me saying at most? If it's less than 2, it means it's at most. Actually, it's just not even quite 2. So can somebody give me a number? So if I start at 1, what number is at most 2 away from 1? There's 2 numbers, right? Yeah, if I go, well, careful. So here's 1. So what number is 2 away in this side? 3, there we go. 2 steps, right? And what number is 2 away on this side?
Negative 1.
Negative
No, negative
1. Okay. So the answer should have those numbers in it. Can 3 or negative 1 be part of the answer? 3 is exactly how far away from 1?
2.
And it's supposed to be less than 2 away, so 3 isn't part of the answer. So actually, I know the answer is negative 1 to 3. Done, right? Will the equation always let me think of it physically like this? No, shit, so we better see what the algebra looks like. So I like to start with a really basic one that we can think physically about, and then see that the algebra gives me the answer at the same time. So then when the equation gets worse, I can trust it to do the right thing. Let me stop for a minute. This makes sense. Again, absolute value being distance is huge, because it gives me another way to look at basic problems. So we already know the answer is supposed to be this. And I really want this to make sense. Why does the answer look like that? I call an absolute value less than equation, I call it the haunted house problem. You're going to go into a haunted house, you want people with you to stay near you, yes? Don't get further than 2 feet away from me. We're going in a freaking, what the shit, right? Are you guys kind of with me? Maybe? I don't know, you could be like, get away from me, I want to experience it. No, me, I'd want people near me, right? Okay. So the less than is always going to look like this. It wants to be a closed thing. It wants to be close to something. You'll see what I mean when I get a greater than what it looks like. It's going to be away. So what would the algebra look like for this? Well, this is where things get a little bit weird.
Can I ask a really quick question?
Yes.
Would it be away from 1 or from negative 1?
No. If it was plus 1, then it would be away from negative 1. How far apart are 7 and 8?
1.
What operation did you use? Subtraction. So subtraction tells you how far apart things are. Absolute value makes it positive, so then that's real distance, right? So this does mean the distance between 1 and a number. If it was plus 1, that would be x minus negative 1. That would be the distance between negative 1 and a number. So I'm glad you asked that. I was thinking about saying that earlier, but I didn't want to make things too weird, but that's true. That's good. Okay. So we're going to do the same problem, or we're going to do algebra to it. Part 2, the revenge. Yes.
For your answer, -1 and 3, why wouldn't you put brackets?
Oh,
Would
How
it
far is
be
-1 from 1?
2?
It's exactly 2 away. But I need all the numbers that are less than 2 away.
Oh, okay.
So that's why we don't include -1. But is -0.9999999, is that less than 2 away from 1? Yes.
Okay.
So that's why I go all the way up to -1 and then say, no. Okay. So I'm still gonna have 2 cases, because it's an absolute value, I need 2 cases. Now here's where things get interesting. So either x minus 1 is less than 2, or x minus 1 is greater than -2. Because remember, I want you to remember, remember how absolute value of x was x or -x, right? Remember that? So I could actually, I don't like doing this, but I could teach that you make this the positive or you make this the negative. So you could actually teach this, don't write this down. You can actually teach this way, but then you can see when you divide by a negative, that flips the sign. So if I want to be close to 1, right, I want to be less than something but greater than something else. Does that make sense? So less than something but greater than something else. So when I rewrite a less than absolute value inequality, it's this less than this or this greater than negative this. That keeps it contained. So let's see if we get the same answer. And I'm sorry, I don't know why I wrote 4. It's got to be and. So a way to remember this is less than, right? If you want to, one of those goofy little ways to remember something. So how do I solve this? This will just be x
It's
less than 3 and x greater than -1. Isn't that what that says? It's got to be less than 3 and greater than -1. So it's got to do both. So another way to write, so I want to show you the ultimate shortcut algebraic way to do this. So I wanted to show you specifically the 2 cases. But let's see if this, you recall this. There's a nice way to rewrite this problem. If I have a less than problem, I can always rewrite it as x minus 1 less than 2, right? Greater than, so you read it this way, isn't that greater than if you read it this way? -2. So it's between -2 and 2. Contained. It's between -2 and 2. So now, you guys know how to handle this kind of equation? If I add 1 to one side, I must add 1 to all sides. So add 1, add 1, add 1, which is basically doing all this at once. -1 less than x less than 3, you get the same answer, yay! Okay. You guys look excited about this, all right. Okay. So then, the really good question is, what the hell happens if it's greater than? Okay. All right, so now we got another example. Let me say it like this: greater than. Another silly little thing. So when it's greater than, it's an or. So if I had, let's say, x minus 5 is greater than 2. Now, why do I keep using it? Let's use this. Greater than or equal to 4. Let's just change some stuff up. Okay. Greater than or equal to 4. Can somebody tell me in English, using the word distance, what this is asking? Anybody? I want the distance between a number and 5 to be at least 4. So let's just think of that physically. Here's 5. What number is at least 4 up from it? 9. And then up here, right? At least 4 away. So it could be 5 away, 6 away, 7 away. What number is at least 4 away this way? 1 and that way, right? So I should expect to get an answer that's like this. It's got answers up that way, answers down that way. So it's going to be 2 separate things. I call this, and this hopefully this isn't triggering, but I call this the restraining order problem, because you have to be at least this far away from me at all times. So you can be over there if you want to, and you can be over there if you want to. You just can't be here, yes? Okay, maybe. So we already know the answer. Can somebody write this in interval notation? What's the lowest it could be here? It's up to 1, yes? Not that. From what? Negative infinity. Up to 1. Am I going to include 1? Yes. Or, does that symbol look familiar? Or? What's this one? From 9 to infinity. Cool. So I already know the answer, and again, it's because it's a very simple equation. So let's see if we do the algebra, if we get the same answer. So it's the same idea. What are the 2 cases going to be? Either x minus 5 is this, or x minus 5 is no, less than or equal to negative. And so sure enough, when I add 5, there's my 9. X greater equal to 9. X less than or equal to 1. Bam. There they are. So physically, it matches with algebraically, which is always good. Maybe? Maybe? No?
What if there's a positive inside the absolute value bracket?
Again, if it would have been plus 5, then I would have put a negative 5 here.
Okay.
Right? Because then it would be minus negative 5. Yeah. So you need the minus to designate
distance.
distance. Yeah. Difference between things. Yeah. All right. So the next, you guys ready? So the next topic is everyone's absolute favorite algebraic topic. Word problems, right? So we'll do some basic word problems, and then I'll let us out a little bit early. Don't get too excited. We got till 9:50. I always forget. 9:50. Bam, 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 bam. Internet's been wonky. Okay. So I'm going to take this away. You just got to get in there and try these. A few people asked me questions about this, so a few people are in chapter 2 homework, which is good. Just to remind you real quick, if you have any trouble with the book, any trouble accessing the book, whatever, I put the PDF up in Canvas. So you just grab that, download it, print it out. If you want it printed out and you don't have a printer or your internet's wonky, just come see me, right? We'll work it out. We'll get some copies of stuff. So word problems. People, now one reason people like this, I can't remember, did I put this on the syllabus? And of course the internet's down, so. I love the little Peanuts clip. Did I put this on there with the, only in algebra can you buy 60 cantaloupes and nobody worries what the hell's wrong with you? Yes, okay. So one reason people hate word problems is they're so frickin' stupid. Have you ever seen the problem where there's a guy who's like, I forgot how much money I put in these 2 accounts, but I know how much interest I made. Who is this person? Who's got so much money? Like, oh yeah, I'm like, I know exactly how much money I got. I don't know, okay, so I'm obviously, not rolling in money, but. So very often they are just really silly problems. So it's harder for you to even imagine ever using it in your real life. So this I understand. But let's try a few problems out. Let's see if we can make this make sense. One problem I like to kind of start with is, let's say we're going to have an event and there's going to be adults and kids. Does anyone have kids, by the way? Anybody, children? Yes. Don't you want to have a certain number of adults given a certain number of kids just to help kind of like play some defense, right?
Activities,
Say again?
like tickets,
Like pickets?
like,
Chaperones.
Sorry. Oh, chaperones, yes. Chaperones are really just sometimes physical barriers, depending on the age of the kid, right? Stop. So let's say we're gonna have an event. We're not sure how many people are gonna come, but we're gonna make it so that the number, let's say that we want the number of adults to be 2 less than twice the number of kids. Let's say, right? I could have done it the other way. This is fine. So we want the number of adults to be 2 less than twice the number of kids. So for example, what would make it easier to figure out if I told you how many kids were there, if I told you how many adults were there? Which one should you know first, and then you can build the other one? If I knew how many kids were there, then I could just do 2 less than twice that, correct? So don't we need to know the number of kids first? So I told you there were 10 kids there. How many adults were there? 18. Twice, what did I say, 10? Twice 10 is 20, minus 2 is 18. Does everybody see how you have to know the number of kids first? Now, I don't know what the number of kids is. I don't know. So in algebra, what do when we don't know something? We call it a variable. We call it x. Why do we do that shit? So then we don't have empty space. We have something, x. We can do stuff to it. So the very first step of most word problems is either going to be draw a picture. In this case, I'm not going to draw little kids, whatever. It doesn't seem right. I'm going to, the very first step normally is, what is just x? Which thing do I need to know first? I have to give it a name first. So we really are translating from English to Mathish, which is why it's so hard. It's one of the hardest things to do. If you've learned different languages, you know exactly what I mean. So the first step is, I've got number of kids, and I've got number of adults. That's the 2 players in this problem, correct? And there's one thing I haven't told you yet that I'm going to tell you in a minute. I'm going to give you this one more kind of line to this problem. I'll give it to you in a minute. So if I say the number of kids that were there is x, then I can build how many adults were there. How many adults were there then? Adults are 2 less than twice the number of kids. So what's twice the number of kids? 2x. And what's 2 less than that? There. So I've given math names to the parts of the problem. All right, so here's the one thing I haven't told you yet, because I can't do anything. I don't know. I need to know something. So what have I told you? The total number of people. The total number of people there was, oh, what you got, Jeff? I need something that'll work. Yeah, that'll work. 31. Yes. Okay. Say again. Make what equal to 31? All right, now watch this, watch this. If I say 2x minus, this is not right, by the way, but if I said 2x minus 2 is 31, what does 2x minus 2 represent?
Adults.
Adults. So now you're saying there were 31 adults, which means there were no kids. That doesn't make any sense.
That would be
So what are you missing here?
plus x.
Freaking kids, right? So you have to add both of these. Kids plus adults makes the total number of people, right? Okay, maybe. So you gotta make sure that your equation, here's what we're not used to. The equation has to make physical sense. When you're doing a word problem, the equation has to make physical sense. Some of us just think, a lot of us skip this, and you see 2 less than twice, that's 2x minus 2 equals the number they gave me, and then you do it, and you get half a kid and half an adult. That's not good. Probably not a good day, right? So you got to include everybody. So now what happened? Now you just solve this. Now this should be the easy step. 3x, add 2, divide by 3. What's this mean? 11 kids. So how many adults?
21.
Yeah, 22 minus 2, 20 adults. And how do you check your work? Well, 11 kids, 20 adults, 31 people. Yay! So you can check your answer, yes.
Can you say, 2x minus 2 in a sentence?
Oh, well, this is twice the number of kids, less 2, right? 2 less than twice the number of kids. 2 less than twice the number of kids. So if I call the number of kids x, the number of adults must be twice that minus 2, right?
Oh, I didn't put that one.
No, okay. Some people put this. And then you get negative people, which is neat. I don't want to go to that part. I don't know, what does that mean? Are they gonna, we bump into each other? Do we annihilate? Oh, we want pure energy. No, I don't want to go to that. What's wrong? See, so people see 2 less than, so you say 2 minus. That's not right. What is 2 less than 10? 10 minus 2, 8. So it's English's fault, if anything, right? 2 less than 10 actually means 10 minus 2. And that's just English, right? And if you learned English as a second language, you know that English is weird as shit. We grew up, and a lot of us grew up in it, we're like, I don't understand what you're saying, but it is weird. Okay. Is that all right? So you gotta, when you do a word problem, you wanna make sure that you answer the whole problem, right? So this, I should have said how many kids and how many adults were there. So you're gonna look at the question, and you're gonna make sure you answer. You don't just get X and circle it, because there's other parts to the problem. Okay. How we doing?
Do you always want x to be negative in word problem? I mean, do you always want x to be positive in word problem?
It depends. Most of the time, it's going to represent numbers of things, and it can't be negative. But couldn't it represent temperature in Alaska or something? So it depends. In the physical situation, does negative make sense? So if I'm building a shed, and you tell me it's got to be -7 foot by -5 feet, I ain't stepping in the damn shed. Huh? What did you make that out of? So quantum star material. No, I want to do that. All right. Does that make sense? So yes, negatives could happen if they make physical sense. Word problems need to normally make physical sense. So a lot of times negatives can't be the answer because they're representing lengths and so forth and numbers of things. Yeah. Okay. Let's try one more. I do have a word problem handout. I'm going to throw that up in Canvas. But I just didn't think to print it out today, so that's, sorry about that. And it kind of goes over the steps. So let's do one where drawing a picture is helpful. So our standard, lovely, there's some dude wants to build a garden, to make a garden, and he wants to fence it off. He wants the length of the garden to be 6 feet less than 3 times the width. He just wants this to happen. So let's say he ends up using, gotta make something that works. What do you think? Bum, 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 bum. All right, so he uses 76 feet of fencing. What are the dimensions of his garden, right? So this is a rectangular garden. I could even state that to make it a little more clear. So the first step really is, so I call it step 0, I think. Step 0 is draw a picture, because sometimes drawing a picture isn't helpful. But here it will be. What are the players in the problem? Not the variables, and there shouldn't be more than one variable, because there's only one thing that builds everything else.
X, the amount of.
That's the formula I'm going to use. But what are the players? What are the parts? Length and width. These are the things that go into making, and I'm not gonna use area, I don't care about the area, right? What is it that I care about? When I fence off this garden, what am I actually creating? A perimeter. I'm not trying to cover the garden with fertilizer or something, I'm trying to fence it in. So that's perimeter. So it's gonna come in the next step, is when I create the equation, it's how the players interact. Now, which one of these do I need to know first? Which one does the other one depend on? I have to know the width first, because the length is shit to do with the width. So I gotta know what the width is first, and then I can do the shit, right? So what do you wanna call the width? You can actually call it W. Let's call it W. So you pick, so draw the picture if it makes sense. Now I can start to kind of label it. Write the players in English, and then figure out what their math names are, which means which one is gonna be just a letter. And now that I know the width is W, what's the length? 6 feet less than 3 times the width. What's 3 times the width? 3W. What's 6 feet less than that? So let me show you, don't write these next things down. I'm gonna show you the several levels of wrong work, right? So the first level of wrong work is somebody doesn't do this, and they don't do this, and they just see this. So they do this. Equals 76. Physically, what does that say? Now that we have done all the right stuff, what does that say physically? What is this? That is the length. So this dude went and bought 76 feet of fencing, and he just made a length. Wah! Is that going to keep the rabbits out of his garden? No, the rabbits are going to just go around the damn thing, right? And they're all like, oh, cool, this guy doesn't know shit. He doesn't know math. Okay. So then I see this, which is a little bit better. It's a little bit better, but it's still wrong. How far did you make it? Halfway. So again, rabbits, this isn't here. They're like, oh, okay, oh, yummy, yummy, right? So to get all the way around, I actually need W plus this plus W plus this. I need to kind of add everything twice. So I need, let me make some more room here. So I need, if I start here, W plus 3W minus 6 plus W plus, now I made it all the way around, and that's going to be my 76. Now, I'll do this problem, and then I'll show you what I do. I do a little shortcut, but let's do this problem. Now that I've got the formula set up, that's the easy step, solving this thing. So take a minute and just solve that for me. Oh, good, it actually works. It's nice. All right, so this should be the easiest step. 4 W's, 8 W's, minus 12, so add 12, right? So you should get W is 11. What does that mean? The width is 11 feet. There we go. Units are important. If you don't put the units on, I'm just going to be a dork. I'm just going to say 11 shoes. 11. You know, don't make me do that, but I will. And so what's the length? 33, right? 33 minus 6. 27. Fit. And if you check this, 27 plus 11 is 38. And if you double that, so you get all the way around, 76. It works. Okay, I like it. I like it a lot. Okay. So I will post that word problem thing. I do want to do one last thing, and then I'll let you out of here. I'm going to hold to my promise. We're going to get out a little bit early, not crazy early. Yeah, better. So I will post that word problem handout, so you kind of have it sitting next to you as you do the word problems. I want to ask you this question. Does anyone know, and this is sort of getting into chapter 3. Oh, shit. Does anyone know what this means? See, that's one thing I could do to it, but what does it mean by itself? Good. It's a function, I love it. So f of x is that. So it's just a prescription. It just tells you f of number is this. You do this to the number. That's what it means. F of x equals that. So if I ask you, what is f of 3, how would you do that?
3 squared.
Yeah, you just plug it, so wherever x is, you're instead gonna put a 3 now. And what's 3 squared minus 3 times 3? Big ass, right? Does this seem familiar? Function notation? I like it. So what would f of w, what would that be? Yeah, w squared minus 3w. So the idea of function doesn't care what's in there. Whatever's in there, just blindly puts it in. Lock it. So one more, let's see. What is f of x plus h? Man, Jeff.
X plus h.
Try it out. Yeah, do it. Write it down. So remember, the idea does not change. There's a little bit to work after you put it in there. The biggest mistake I see is somebody just writes this and puts a plus h at the end. That ain't right. You gotta replace this. What do you replace this with? X plus h. So you square it, and then replace that with x plus h. And now you can do what with this? How do you mean solve it? Yeah, write it twice, FOIL it, so you get x squared, plus hx plus xh, plus, so you get plus 2 of these, plus h squared at the end, minus 3x, minus 3h. And there's no like terms, so you're done. Now, a really good question is, why would you need to do that, Jeff? So, help me, remind me, I don't know if I asked you this. How many of you guys are thinking about calculus, going into calculus? Anybody? Any of you guys?
Have to.
Oh, many of you. All right, sweet. Hello. Some of you guys like, that's great, you love it, Jeff. This is gonna be huge. Crazy huge. It's the underpinning of one of the two major ideas in calculus depends on you being able to do this. And this is not that hard, right? Of course, you do extra shit with it after you do this, but still, this is the first step. Can you just put that in? Yes, you can. Okay. Last thing about functions, and then we'll do more about functions. The last thing about functions today, right? What is the definition of a function? So this is sort of, that's just how to work with function notation algebraically. But we have a definition of what's allowed to be considered a function. I don't know if anybody remembers. Let me show you some graphical. So one of these two things is not a function. Any idea which one? First or second?
The first one.
First one is a function.
The second one.
And the second one is not. Does anyone remember why the second one is not a function?
The vertical line test.
Vertical line test. It does not pass the vertical line test. What the shit? Why vertical line? I don't know. So let's talk about the definition of function. Anybody ever seen either the movie or the TV series Highlander? The Highlander? No? Nobody at all? That's okay. That's okay. It's my own little joke. I'll keep it to myself. The definition of a function, give myself some more room. I'll put it right here. Definition of function. It's a relationship. It's a relation between two variables, x and y, where for every, it could be x and y, it could be other things, but right now it's x and y. For every input, Jeff, you need it, x, there can be only one one is my little joke about how it's a relationship between two variables. So these are relationships between two variables, right? When x is this, y is that. When x is this, y is that. Blah, blah, blah. What's the problem here? What about this x right there, this x? How many outputs does it have? 3. So it's not a function because there's an x where there's more than one output. That's why the vertical line test is just a visual of the definition. If I draw a vertical line, that's an x. If it goes through more than once, that x has more than one output. So we just don't call it a function. Now, real quick, why do we create things known as functions? If I throw this marker in the air and I say 2 seconds later, where is it? And you say it's 5 feet up and is 2 feet down below the ground, does that make physical sense? Or even just it's 5 feet up and it's 10 feet up. Does that make sense? So to make physical sense, for a lot of situations, there could be only one output for a given input. If I said, where were you on the night of June 23rd? And you say, I was at the mall and I was at, on the night of June 23rd at 8:11 p.m., right? So I have a very specific input. If you tell me you were in 2 different places, that's a problem. Or teach me, right? If you could do that. Does this make any sense? So that's one level of why we like to designate what are functions, because they can represent physical situations where you can only be in one place at a time or so forth. Okay? Does that make a little sense? Does this sound familiar, functions? I know you guys have all worked with functions to some degree. All right, so I think that's enough for today. We've done plenty. So next time, we'll start with the quiz. We'll get back into chapter 3. I might have a little group work for us finally, so I can shut up for a bit. That'd be great. Let me know if you have any questions coming up, or otherwise I'll see you tomorrow.
Thank you, Professor.
Sure. Oh, I forgot about my name. Oh, yeah, so, all right. Oh, here. But I gave you, did I? Wait a minute. What's your name?
Thank you. Thank you.
Yeah, I sent that to you, right? Didn't I send it to you?
I got the syllabus, I got your office hours.
Syllabus, office hours, and the homework. And what else did you need? Oh, the textbook.
I just had to do the final ones, and I
sorry.
searched 62.
So here's the great thing about the textbook. Let me reply to you.
That's
I'm
what
gonna
I'm staying
give
over.
you
I'm like, cause I
the
didn't
link
remember.
to actually get it yourself.
I don't know, it's
So
also
in
the last
Canvas, I got
problems when
the
I finished
PDF,
it, but, I mean, this
but I've
is
also
the-
got this.
Which one?
Get over here.
56
Where's my
on
mouse there?
chapter 2.
So let me go here, I'm gonna copy this to
I
you.
need, I really need one.
So here, this is the book, so you can get, view it online,
I feel like
you
when
can
I have the
download it.
answer
If
to
you're getting
this
this
one,
as an
it'll
actual
kind of like
touchscreen.
piece together the other
View it
ones,
online,
'cause I'm
download
like,
PDF, or you can
a
actually
lot of
order,
them I've
print copies
started,
if you
but
want
just
from
haven't
Amazon,
finished, cause I'm
to
like,
see if they're there.
okay, I clearly need help.
No. So they should be around $60, but you do not need a hard copy if you don't want it. So let me copy this down. Cut that and send it to you. There you go. So that's the direct link to the book, so you can download the PDF, you can view it online, you can order a print copy. Cool. Great, thank you. No worries. Oh, I'm still recording. What's
Yeah,
up? So, the really
So
exciting
I
part.
kind of just came in because I was